Hello class, welcome once again to our discussion for today. So let us now solve problems in relative motion that is very similar to that concept, but we cannot simply use that principle to solve this problem. It's almost a similar problem. So let us look at this variations class. So we have here a problem saying that a small ship capable of making a speed of 6 knots through still water maintains a heading due east while being set to the south by the by an ocean current. The actual course of the boat is from A to B, as shown in this picture. A distance of 10 nautical miles that requires exactly 2 hours. So from A to B, so this is no 10 nautical miles and can be reached after 2 hours. So now the question is determine the velocity of the current of the water, no? Vc of the current and its direction theta measured clockwise from the north. Okay, so this is the given illustration. So we have here the angles were given, that is 10 degrees. So this kind of problem class cannot be solved easily using the concept that we have discussed in relative motion. So to solve this problem, we have to make use of the concept of the law of sines or the law of sine and also the law of cosine. So for the law of sine or sine law, so we have this sine A, sine capital A over small a equal to sine capital B divided by small b equal to sine capital C divided by small letter c. Okay, so in this one class, this represent the side that is opposite to this angle A. So B is the angle opposite to the side B, and so on. So where A here, A, B, and C, the capital A, capital B, capital C, these are the angles, and the small letters A, B, C, these are the sides of the triangle. Okay, now for the law of cosine, so from this illustration, having this triangle having a side ABC, angle alpha, beta, gamma. So to solve for C, so C can be related to these two sides and also the angle between these two sides in this formula. The square of this side equal to the sum of the squares of the remaining sides, okay, minus twice the product of the remaining side and their included angle. Okay. And similarly, if you want to solve for B, you just use this pattern class. And so do with when you solve for A. Now for C, solving for C, you just take square root on both sides. You'll get this value for C. Where C, A, B, these are the length of the sides, CB, CAB, and gamma is the angle opposite to C. Okay, so angle opposite to C. All right, now we let here C stands for the current of the water, and B here for the boat. Now the solution here is you just make this triangle here, where this side of this triangle, this is the given speed, no speed in 6 knots, speed of the boat in still water. So that is the direction, 6 knots. Okay, and we have here the five knots here is taken from 10 nautical miles that requires exactly 2 hours. So it means in 1 hour it covers only half. So half here is equal to 5 knots. And we are asked to determine the speed of the current, meaning the VC, and its direction theta that is measured clockwise from north. So this is our north direction. This is east. So theta or the angle that we need to measure is the angle from the north, measured from the north towards this VC. Okay, so we noted this as our beta. All right, so using the law of cosine, so we have this side. This side can be solved using this formula. So square of the side, okay, we have here, and then sum of the squares of the two other sides, then minus twice the product of these two sides, 5 and 6, then cosine of the angle between them, or the included angle, which is 10 degrees. So here we got VC equal to 1.383 knots. All right, so next we have to solve for the angle. We have already one angle here that is 10 degrees. Now to solve for the other angle, so we can make use of this law of sine. So we have, for example, if we take this side here, take note, class, that we have sine A over A equal to sine B over B, sine C over C. You can also invert it. It means that you can put it as in the numerator and this one in the denominator, and so do with the others. So that is similar to these are just the same, that is still sine law or law of sines. So that's why we have here 5 over sine theta, meaning this side here, divided by sine of the opposite angle. So this side opposite angle is this theta. So we have 5 over sine theta equal to this side, which is VC. So VC, which is we had calculated 1.383, divided by sine 10 degrees. Okay, so in this case, we can solve for sine theta. So you just, okay, so you can, actually you can use this one without inverting, class. So from here, you get sine theta equal to this one. So using your calculator, so theta, take the inverse of this value, and then you get the theta 38.9. Okay, so theta is solved, 38.9. All right, so beta therefore is, so from here, you know that from here up to this one, that is 270, right? This is 270 because this is 90 degrees, 90 degrees. Okay, and then you have here, this is this horizontal angle, that is 180 degrees plus 90, so that is 270. So from here to this side here, this side, that is 270, then minus this angle, so that will be the value for beta. So our beta is equal to 231 degrees. Okay, so I hope you understand this problem, class, and the process on how to solve this problem. I think in your midterm exam there will be a problem related to this one, and I hope you can use this concept to solve that problem. And also, if the problem is about airplane, so the same concept, class, you just apply this concept. All right, so thank you very much for listening, and good luck to your uh, midterm exams. Bye.